Hey guys, so I just wanted to give you a quick tutorial on SAP. This is going to be specifically for your homework 7, and it's kind of piggybacking off of the screenshot tutorial that I posted a couple weeks ago, but we're just going to go a little bit more in depth, and I think it'll be a little easier to grasp what we're talking about if I just screen record what I'm doing on the computer. So obviously, first and foremost, make sure you have SAP on your computer, or you're navigating to the second floor computer lab or the computer lab over in 15 Metro Tech so that you can use the program. So when you start, open up the program. You're going to click the icon in the top left corner that's like a little piece of paper with the corner folded over, and open up a new model. From there, you're going to make sure that the units are pounds, inches, and force, and then click grid only. So the grid pretty much just makes it easier for you to define certain pieces within the structure that you're creating. So for now, you can just use these arbitrary numbers, and the grid can pretty much be whatever you want it to be. So click OK. We don't really need this window 2 on the right. You can keep it open if you want, but if not, just close it out so you can have a bigger view of what you're looking at. As we see on the screen right now, it just looks like one small line. It's because we're looking in the y-x axis. So what we're going to do is navigate to that top bar and click XZ axis instead. So then we'll be able to see our entire grid. So you can scroll around, zoom in, zoom out. From there, we're going to start drawing our cable. So in this case, it's just one straight line since this model is doubling as our acrylic piece. So on the left side, click the little icon for draw frame / cable. And then the way we set up our grid, you're going to draw your points for your acrylic piece right on the grid points. So click one, click another, and then just hit escape. So right now, this simulates our acrylic piece just standing up straight. As you guys all know, in this we had a fixed end on the bottom, so that's the first step we're going to do. So all you want to do is highlight that bottom grid point, go to Assign, go to Joint, and then Restraints. As you can see, we'll have fixed points, rollers, all the different restraints that you guys can use. Translation 1, 2, and 3, rotation 1, 2, and 3. So this first icon we chose right here is fixed, so just click on that. So that checks off translation 1, 2, 3, and rotation 1, 2, 3, because as you guys know, with a fixed point, it rejects translation and rotation in every single degree of freedom. From there, just hit apply. And then you'll see on the grid that is on your screen that there is a fixed point now at the bottom. So the next thing you guys are going to want to do is go to Analyze, Set Analysis Options, and we're going to switch from plane frame to space frame. The reason that we do this is because we want to see the analysis in all degrees of freedom rather than just the XZ plane. So just click on space frame, hit OK. So the next thing we want to do is assign the section properties for our acrylic piece. So you're going to go to the top bar, click Define, go to Section Properties, and then click Frame Sections. So from here you can see that there's already a default section property loaded into SAP. So we're not going to want to use that one. We're going to want to add a new property. So click Add New Property, and then navigate down to Rectangular in the bottom left corner. From here, it's just easier if we switch the name over to Dynamics so that when we are looking at the different pieces later on, everything has the same name. So the depth and the width right here, these are going to be the values that you measure from your specific acrylic piece. So just make sure you measure it and then put the specific numbers in. So I'm just going to use 0.1 and 1.5, but just make sure these numbers reflect what you guys measured. From there, if you look in the bottom left corner, you'll see the text box that says Material. We're going to click the plus button to add a new one, and then add new material on the dialog box that pops up. So as we can see, the different properties it gives us are region, material type, standard, and grade. Click on material type, and we're going to navigate down to Other, which means that we're going to have user-defined functions upon our material. Click OK. And once again, we're just going to change this name to acrylic, since that's the material that we're using. It's just easier if you use your own name so that when you're going on to more complicated pieces and having different materials and different properties, we're not following along with the SAP user-defined names because they can get a little bit confusing. So for this particular assignment, we are going to neglect the weight of the acrylic piece itself, so just make sure you change that to 0. The modulus of elasticity and the coefficient of thermal expansion are going to be values that you either calculated yourself or looked up. So just make sure you input those numbers and then click OK. From there, you're going to click OK again on Define Materials. And then once we get back to that original rectangular section dialog box, we're going to go back down to the bottom left corner where it says Material. Click the drop-down menu and make sure you change it to acrylic. Then we're going to hit OK, and OK one more time. So now that we have defined our section property, we just need to make sure that it applies to the piece that we created in SAP. So just highlight that entire section we made, go to Assign, go to Frame, and then Frame Sections. I'm just going to click on Dynamics in the dialog box, and then hit Assign. So if you did everything correctly, SAP should display the name of the frame section that you applied, just as a double check. Just like I said before, when you get into more complicated pieces where maybe one frame section is one material and one is another, SAP is pretty good at differentiating between the two. So the next step we're going to do is assign a mass load at the top of our acrylic piece. So this is going to be pretty much representative of your phone when it was attached to your acrylic piece. So what we do is highlight that top grid point. Make sure you're only highlighting the top and not the entire thing. If you highlighted the entire thing, you would be changing 2 grid points, which would mess up the analysis a little bit. So just highlight that first grid point, go to Assign, go to Joint, and then scroll down to Masses. From there, just pull that dialog box over. So when it says Specify Joint Mass, we're going to do it as a weight, since you guys measured the weight of your phone. Going down to Mass Coordinate System, we're going to change that to Global, just as I said before, just so it records all of the degrees of freedom. And then from there, we're going to want to put the weight in the global x-axis. So this is just going to be the weight of the phone that you measured. So for mine, I'm going to use 0.3 pounds. And then one good tip to do is in the options on the bottom, just click Replace Existing Masses, just in case you go through and edit these. You don't want to have a ton of different masses in one point and you don't realize it. So just do it, Replace Existing Masses, hit Apply, and you should see a number pop up on the top of your acrylic piece and the grid point that you placed it at, and then click OK. So from here, we are ready to run our analysis. So just navigate to the top bar, click that Run Analysis button. So as we see, right now we have 2 different cases. If you did have a load applied to your acrylic piece, like we did in the first tutorial, you would have another case name that said Live Load. So when we're running these tests in order to find the natural frequency, we want to turn the dead load off, so we don't want to run that. So click on Dead Load, click Run Do Not Run case to switch that action to Do Not Run, and then make sure your modal case is set to run. From there, just click Run Now. And then shortly, you should see the deflected shape for your acrylic piece, as we see right here. And then on the top, you'll also see the period and the frequency that SAP will have calculated for you. Obviously, these numbers are a little bit different than what you guys are going to get. Every person should get slightly different since we're using different acrylic pieces and different phone weights. So just make sure that when you compare what you get in SAP to what you get with the shake table, which we will be doing later, the numbers match up. If for some reason they don't, just go back through and rerun the SAP analysis and maybe come back through and rerun the shake table analysis until you get numbers that match up. From there, you're pretty much all set. If you want to display, instead of just having it right here on the top bar, you can go to Display, Show Tables, click on Structure Output, and then do Modal Information, hit OK. And scroll down to modal periods and frequencies, and everything should be the same right here. And then you guys are all set. So just make sure you save your files and just have double access to them in case you need to reopen them or change anything.